All right, today we're doing exercise 5AB, exponential graph notes. This is probably going to be one of the much easier chapters compared to the ones before because you've done it pretty much year 10, year 11, mostly year 11, and then now year 12. So let's do a bit of recap again. Let's see what you remember. A, in terms of transformations, chapter 3, what does capital A here, or the A in front of the base for an exponential, represent? What does it do? Which part of the transformations can I please have A for Adonis? Good, it is a dilation, but which dilation is that? Let's go with Ishan. What is A? Dilation of factor something from? From the X. Very good, which means it affects your Y's. It's a vertical stretch, okay? So from the X, it's a vertical stretch. And then B, which is really just the base. Okay, so that's the base of the exponential. And then we've got N over here. What is N? N is the, what is that? Let's go with Jacob. Good, this is dilation from the y-axis, which is a horizontal stretch. Usually if it's just a whole number like 2, then remember it's the reciprocal, it becomes a compression. So e.g., if n was equal to 2, then it's a dilation of factor half from the y-axis. Just be careful with anything to do with the x's, it's reversed. And then C, what is C? C should be the easier one. Let's go with Alicia. Beautiful. We've got a horizontal translation, and then obviously last one, which most students are able to identify. D is your vertical translation. Obviously, what I'm missing there is any reflections. So where A and N are, that determines. So dilation reflection is pretty much the same thing. One's negative and one's just timesing. So if you have a negative on this one, then it's a reflection vertically. And then if there's a negative on the N, then it's a reflection horizontally. Okay. All right, here we go. Let's look at domains then. So we know that an exponential graph usually looks something like this. There's some key features there. So I've just drawn a graph there. When you draw the graph, you must label a couple of key features. Asymptotes. Where is the asymptote in an exponential graph? A simple y equals 2 to the x. Where is the horizontal asymptote? Let's go with Zach. Horizontal asymptote of y equals 2 to the x. Good, but you have to write the equation. Very good. So it's y equals 0. So when you're doing the graph, make sure to actually write the equation. Don't just write a 0 here. They will not give you the marks. So you must actually write the equation of the asymptote. Y equals 0. Y-axis intercept. Usually if there's no translations at all, no reflections or anything, then what would the y-intercept be? Let's go with Krish. 1. When x is 0, 2 to the power of 0 is 1, or anything to the power of 0 is 1. So the y-intercept, one of the key features of an exponential graph you must label. We were labeling the asymptote, equation of asymptote. When you do the dotted lines, make sure to use a ruler. Sometimes examiners can be picky with that. And then finally, reading the domain and range. Should be pretty straightforward from here. Domain, what is the domain, Jason? All real numbers. And the range, let's go with Luke. Very good. 0 to infinity, non-inclusive of 0. Which you could do R excluding, actually R plus excluding 0, or just R plus. Would have been fine. R plus is good too. All right. Those are the key features. That's just general explanation. That's pretty much 5A, 5B in terms of theory. What do you do in 5A and 5B? You're sketching and solving. So as long as you can do your algebra and solve, going back and forth, so log versus exponential, that's pretty much what 5AB is. So let's do the first example here. We got 3 times 2 to the 5 minus x plus 1. If we were to read the transformations directly from the graph, give me one transformation you can see. Let's go with Leo. Good. Dilation factor 3 from x-axis. Good. I can see that. That's the 3. What else do I also have? Can I please have, let's go with Erwin. What transformation can you see? Very good. So up by 1. Up by 1. In translation of 1 unit in the positive direction of the y-axis. That's the proper way of saying it. So up by 1. What else do we also see? Let's go with Anne, who just came in. Anne, read a transformation that you can see from this equation. Very good. Translation of 5 units to the right. So right by 5. And then the last one. A reflection of what, Vibha? In the what? In the y-axis. Very good. So reflect in y-axis because it's affecting the x. So it means it's swapping horizontally. That's what the negative to the x is doing. It's a flip, horizontal flip. So we can picture the graph. It usually looks like this. We said it's going to reflect in the y-axis, so it's probably going to look like this. You said up by 1, so I can shift it up by 1, and then to the right by 5, so maybe it just looks like something like that so far. And then there's a dilation of factor 3 from the y-axis, so you can make it a bit thinner. But overall, I expect something like this, and I probably don't expect any x-intercepts at this point. Okay? And up by 1. So here we go. State the asymptote. We should have y equals to 1. So it's gone up by 1. Y-intercept, which is what we need to calculate. So let's calculate the y-intercept. We had y is equal to 3. What was it again? Times 2 to the 5 minus x. Plus 1. Let x equal to 0. So here we go. Y is equal to 3 times 2 to the power of 5 minus 0 plus 1. Y is equal to 3 times 2 to the 5 plus 1. 2 to the 5 is that 32? I think so. 8, 16, yeah, 32. 32 times 3 is 96. 96 plus 1 is 97. So we can say 2. Cool. So let's put it all together. We expected it to be thinner, which makes sense because it's now 97. So 1, I obviously drew it too big here, but we can tell that it must be shot up really high. And you can also prove that the x-intercept doesn't exist by actually trying to solve it, or you can read the transformation there. But let's try to prove that the x-intercept doesn't exist. And some of us might not have been able to identify that. So how do we know that the x-intercept does not exist? So we're minus 1 on both sides. Divide both sides by 3. What do we do next? So let's say, so I know that there's no x-intercepts from reading the transformation, but say if you didn't know that from reading the transformation and you were applying the algebra, what do you do next now? So I did subtract 1, divide 3. I want to find x. Because if I can find x, I can find the intercept, right? What's the next step I would do? Sarush? Good. Log base. Log base 2. So I do log base 2 on the left, log base 2 on the right. These two cancel out. I get 5 minus x on this side, and I get log 2 of negative 1/3. And then to find x, I move 5 across, so minus 5 plus log 2 of negative 1/3 equals negative x, times everything by negative 1. And I should get x is equal to positive 5 minus log 2 of negative 1/3. So I do have an x-intercept. What's wrong? Why? Very good. Right at even just at this point, we can see a couple of things here. And this is what I mean. If you just did the algebra in students, especially exam 1, so they just follow on, and it's great that they know it's log base 2, even if they know how to do that. Let's say they get it here and they're just like, yep, I'll just label that as the x-intercept. But even just reading this mathematical equation at this point, we're saying 2 to the power of 5 minus x is equal to negative 1/3. We just think about that for a moment. 5 minus x, whatever that number is, doesn't matter. But 2 to the power of any number, can you think of any number when you do 2 to the power of something, it's going to get you a negative? Just won't work. Like 2 to the power of 10 just keeps growing. But then you go the reverse section, 2 to the power of negative 1 becomes half. So it gets smaller and smaller. How do you ever get a negative? Right at this step, it's already undefined. The fact that you still continue means that you didn't realize what that actually means. And then even when you get up to this step, not realizing that log of a negative number does not exist. You can't do that. Okay, so just anywhere along those points, you could state log 2 of base x needs to be greater than 0. Therefore, that cannot exist. Or even at this point, you could have said it as well. But the fact that if you go all the way through, examiners will know straight away. Okay? So I was just pointing out a very typical mistake that students that aren't really strong with interpretation of the graphs. But there you go. Let's label it as 0, 97, no x-intercept. Got an asymptote equation. Fantastic. Cool. Next one. In the last sketching example, but all these examples are just 5a and 5b. Here we go, labeling intercepts and asymptotes. So looking at this equation, let's tell me from a 2 minus e to the x minus 1, what is the equation of my asymptote? Can I please have, let's go with Aryan. Asymptote equation. So just looking at this, what would the asymptote be? If you're not sure, it's okay. Not sure? Let's read the transformations. Krish, what transformations do we have? Not a dilation, that's a... Okay, translation. This is up 2, because you're adding on 2. Yes? Good. This is right 1, and I'm missing one more transformation. Good. Reflect in x. So it's flipped vertically. It's gone to the right by 1 and up by 2. That up by 2 is what determines. So even if I go to the right, it doesn't change the asymptote. So moving it left and right doesn't change the asymptote. And so that right doesn't do anything. The up 2 does. And then reflecting in x just makes it like this. So the asymptote clearly is governed by any vertical translation. So if you see a vertical translation for an exponential, it should tell you the equation of the asymptote. So we know it should be at y equals to 2. Very good. And the right by 1, all that. So we know the shape should be reflection in the x-axis. So it should be something like this. And what I expect is the y-intercept should be below 2. I just don't know where. Could be negative, it could be positive. So hence why we're going to find the y-intercept first. Here we go, y-intercept. You let y equal to 0, x equal to 0. So f of 0 is equal to 2. Take away e to the power of 0 minus 1. 2 minus e to the negative 1. 2 minus 1 on e. And I guess we can kind of guess what that might be. Anyone know what the value of Euler is? E, roughly? 2 point? Yeah, roughly. So when you do 1 divided by 2.7, let's just say 1 over 3. 2 minus 1 over 3, is it going to be positive or negative? Positive. Okay, because that's a pretty small number. It's smaller than 1. So 2 minus something that's smaller than 1 has to be in the positive region. So that's not a bad estimate. Okay? So I could just label here 0, 2 minus 1 on E. There we go. I've got my y-intercept, and it looks like I do have an x-intercept X-intercept, here we go. Let's work out x-intercept next. So x-intercept occurs when y is equal to 0. So you got 0 equals 2 minus e to the power of x minus 1. All right, this is where the practice is again. Exponentials and logs. Move everything across. Do subtract 2 on both sides. I now get negative 2 equals to negative e to the power of x minus 1. You might be like, oh, sir, it's equal to a negative, therefore it's undefined. No, it's because we have the negative over here. So this is possible because it's a vertical reflection. So therefore, you can have negative y values. Dividing both sides by negatives, you now get 2 equals e to the power of x minus 1. And then from here, inverse of exponential base e is log base e. So log base e on the left, log base e on the right. Log e of e cancels out, and you're left with x minus 1 is equal to log e of 2. Okay, and finally, x is then equal to log e of 2 plus 1. You can use ln. Log e is the natural log, so you can use ln brackets 2. So you can write it like this. That's acceptable, either way. All right, and that clearly is going to be a positive value, which coincides with that. So we can say that is now at log and not natural log plus 1, 0. All right, I've drawn the graph. I've labeled the asymptote. Axis intercept labeled. The question did ask for a couple more things. What did it also ask? Can I please have, let's go with Una. What else did the question ask for? Good, so we need a domain and we also need a range. So once you've drawn the graph or you can visualize it, you can answer the question now. Charlie, what is the domain? Yep, and range? Very good. Beautiful. Okay, so that's 5A, 5B. That's why I'm saying it's probably one of the easier chapters to do because it's a big revision of, well, small revision of last year. All right, here we go. Let's pause the video. You got, I reckon it takes you 90 seconds to figure this one out. I'll give you a minute and a half. So a typical multiple choice question. Which one is A, which one's B, which one's C? So on my screen, you can see the purple, black, and green. On yours, you can't. But I'm going to label them. This is going to be called 1, 2, and 3. 90 seconds. Go. Which one is which? And that's it for today's lesson. Here we go. 90 seconds. It's just a practice of reading transformation notation or transformations in function notation.
Writing is not. That's what I used to do back in the day, and you just forget, because you don't get exposed to it.
No, I've tried all of them, and I remember.
No, but reading it from memory is like the best.
Yeah. See what you get.
30 seconds left. Hopefully by now, for most of you, you should be guaranteed which is which. But you have an extra 30 seconds to figure this out. 1 minute and a half is how long you should spend maximum on a multiple choice question end of year. There'll be some questions that won't take you 90 minutes or 90 seconds. In 5, 4, 3, 2, 1. All right, which graph belongs to number 1? Can I please have, let's go with Luke. Which one did you have for number 1? A is correct. How do we know? Well, this is to the left by 2, if you can read it. So the way I do it in my head is I just do 2x plus 4 equals 0, move everything across, and x equals to minus 2. And I know that as a transformation, that would have been left by 2, but that's just how I do it. Usually when you guys do it, this is x and x dash. That's what it is. Okay, but I just let it equal to 0 and just move it across. So in my head, that means it moves to the left by 2, and the only one that's gone to the left had to be this one. Okay, so yes, that is correct. Or you could have also looked at the asymptote. It's gone down by 1. So clearly it had to be A. Very good. Next one. We've got now 50-50 chance. Number 2. What did you get for number 2? Can I please have everyone I've chosen for a while? Let's go back to Adonis. Which one's number 2? B. And B is the correct answer as well. Number 2 is B. We got a vertical flip. So if you think about a normal exponential graph, vertical flip would look something like this. So any shape that looks like that, and out of the 3, there's only one that looks like that. Or another giveaway is again plus 3 up by 3 asymptote. This is the only one that has an asymptote at y equals 3. So yes, it has to be B. And the last one arguably would have been the trickiest had I not given you A and B. This one has both reflections. So if this is your normal graph, it would have flipped horizontally and then vertically. Okay, so that's why the green graph is the only one that matches that. But again, even if you didn't know how to read the transformations, there's still the translation down by 2. That's the only one with an asymptote at y equals -2. So knowing your asymptotes is probably the easiest way to identify these types of graphs for exponentials and logs. But usually in the exam, it's not like that. They usually give you multiple of the asymptotes that are the same. The only difference is the reflection. So you do have to learn how to read the reflections and then apply it into the graph. Okay. All right, team, that's 5A and 5B. And for those who are late, just a reminder, I will be doing the SAC in week 9, covering chapters 1 to 4, which is highlighted in yellow. We did 5A and B today. Friday, I'm away for a hospital appointment with my wife. And I also told the crew, because I believe I haven't told you guys, term 3, I won't be here. So you'll have someone else. And your hardest SAC, I'll be around. So I'll be there to mark this one to get a sense of where you're all at. And then you guys should technically improve for SAC 2 after the first one, and your holidays come back. You're like more motivated and should be anyway. And then some of you will lose motivation and give up. So that SAC 2 really separates it, but it should be very similar to the first one, except you would do better. And the last one, everyone usually does much better. From my previous experience at this school anyway, students who did worse were the ones who gave up already. And that was really obvious by the time they came to the exam. I had my worst score in history after, well, I've taught year 12s now 7 times, but I've taught year 11 methods 15 years now. And that was the worst score I've ever had from an advanced kid too, by the way, meaning they were from an enhanced class throughout the school. So that's what I mean by don't give up. It's one of those subjects that you'll hit your morale and motivation. Don't give up, just stick to it. I had a student, just in that same year, I had a student who was getting like 20% on average throughout of them, and they still beat that advanced student or an enhanced student. So it means it's tenacity over, intelligence. Okay, so just stick to it. Don't give up. It's one of those subjects. You chose this subject. It's fast. It's dense. The more you can stick to it, just keep trying. You will do better than those kids who are smarter but have given up. Okay? Stay tenacious. All right, I'm going to stop the video.